Today in Algebra 1, Chapter 5, Section 5, we are going to write equations of parallel and perpendicular lines. So that we don't have to write parallel and perpendicular out every single time we say them, we're going to use parallel like this to abbreviate for parallel, so we don't have to write it out, and perpendicular is like this. We need to remember that with parallel lines, we know that the slopes are the same. So if you have lines that are parallel, their slopes have to be the same, exactly the same, not even just a little bit close. But if the slope is 1/3 for this line, then it has to be 1/3 for this line. Perpendicular lines are a little bit different. They have slopes that are the opposite reciprocals. So if we have this slope, okay, in order for it to be perpendicular, you have to have the reciprocal, and it has to be the opposite, which means the signs have to be opposite. So if you have a slope of 2/5, then the perpendicular slope is -5/2. Have to have opposite signs, and they have to be reciprocals of each other. Let's look at this example. If you have a line that passes through the point -3, -5, and it's parallel to y equals 3x minus 1. Okay, we have a point right here. We have an x value and we have a y value. And we also know the slope, because the slope has to be the same as this line right here. So we know that the slope is 3. Why do we know that the slope is 3? Because it tells us that it has to be parallel to this line right here. If it's parallel, it has to have the exact same slope. So now we have a point and we have the slope. So we can use point slope form, or we can use y equal mx plus b. If we use point slope, we're going to have y minus the y value, which is -5, so that's +5, equals m, which is 3, times x minus our x value, which is -3, so that's going to be +3 right there. So you have y plus 5 equals 3x plus 9. We distributed that right there to get our 3x plus 9. Now we're going to move that 5 over, subtract 5 right here, subtract 5 right here, and you have y equals 3x plus 4. Okay, so remember, had to have the same slope. So here's our slope. Okay, and it's the same slope as that right there, so it's all good. Okay, we have the same slope. Now we're going to look at a line that passes through the point 4, -5, and it's going to be perpendicular to the line y equals 2x plus 3. Okay, if it's perpendicular to this, our slope here is 2, and we know that the slope that's perpendicular has to be the opposite reciprocal. Okay, so 2 is positive right here, so we know our slope has to be negative, and the reciprocal of 2, which is 2/1, is 1/2. So now we have our slope, and we have a point, and we can do the same thing. Y minus -5, that's y plus 5, equals -1/2 times x minus 4. Okay, let's distribute the -1/2, and we'll have y plus 5 equals -1/2 x plus 2. Again, we get this when we distribute that -1/2 through the parentheses. Now we subtract 5 from both sides to put it in y equal mx plus b. So we have y equals -1/2 x minus 3. Okay, we have to make sure that they are perpendicular. How do we do that? The slope here was positive 2/1, so this perpendicular slope had to be -1/2. It is. Okay, so the world is round. That's good. Okay, that's just a quick review on your parallel and perpendicular lines. Okay, so just a quick review. If they give you a point, okay, an x and a y, and it tells you the line is parallel, then you're going to use the same slope to solve for your line. If they give you x and y, and they tell you that it's perpendicular, then you're going to use the opposite reciprocal. Okay, the opposite reciprocal, you need to remember, if one is positive, then the other one is negative, and the reciprocal is when you flip it over. So if you have a positive 2/3, then its opposite reciprocal is a -3/2. And then you can use point slope, or you can use y equal mx plus b. Y'all have a good day.